Hello everyone, good morning, good afternoon, good evening, whatever time zone you are. You cannot see my face, you're seeing Rob's face. My name is Armando Lacerda and I'll be your moderator here for this session of the 24 Hours PASS about the synergy of in-memory operational analytics that Rob will be presenting in a couple minutes. But before he gets started, we have some slides here to go through with you guys and some words to share with you. So if you need some technical assistance, you have the guidance in there. You have the links there for the Zoom. If you think your screen is too small, work with the Zoom in your screen. Perhaps also can be a Zoom thing on the Windows desktop. You know, the Zoom feature they have there for high resolution screens. I work a lot with that here on my own side. Don't forget to fill up the evaluation at the end when we finish later. Rob, if you can skip that part for the next one. Oh yeah, before you skip, there's on the right side of your screen probably, you have there the question panel. So if you have any question throughout the presentation, you can go ahead and type your question there. I'll be here reading your questions, and when the time is right, we're going to share with Rob and he will be able to answer your questions, all right? All questions will be answered either here online, or you can find answers later on his slide deck on the web and on his blog post. All right, next slide, please. All right, so a big thank you to our sponsors, right? Microsoft, Idera, and Eternity, and SQL Sentry, and Hewlett Packard. These guys are great. They are sponsoring all these events. And you know, PASS is about communities, about users helping users, and it wouldn't be possible without our sponsors. So a great thank you for them. Yeah, if this is your first time you're watching a webinar through PASS and you're joining in the 24 Hours of PASS, we welcome you, and we really would like you to become a member. And I've been a member since you know, the installation of this back in 1998 down in Chicago, and it's a great community. You know, we help each other a lot. Actually, I just got here home. I came from my local chapter meeting here in Sacramento, and yeah, go to the website and join one of the local chapters you may have in your location, or the virtual ones that's going to show up in the next slide. Let's see. Oh, so the chapters, the virtual chapters come later. This first one here is about the summit that's coming next month. Until September 18th, this is the price for your registration, right? For you to sign up and go to it. It's an amazing event. It's a 3 days event with 2 days before that for pre-conference. There's some extra money in there. But it's an amazing 3 days conference packed of knowledge, a great network opportunity. I highly recommend everybody to go because I'm being there since day one. It's a great opportunity. Rob was talking something about getting your wife there, right, Rob?
No, I was pointing out that September the 18th, by the time that comes around in America, it's September 19th in Australia, and that's my wife's birthday, but I don't think that's going to be an appropriate gift. I think, by all means, buy your loved ones registrations for the PASS Summit by September 18th, but I don't think that'll work in my house. I think I'll be shocked.
Right. So if you guys are considering going, please write down this $200 code there, the discount code there for you. If you register before September the 18th, you're going to have that discount. So it'll be $19.95 registration fee for the conference, but only valid until September the 18th. Let's see what's next there. Yeah, so with that in mind, let me introduce you Rob Farley. He's an MCM, certified master, an MVP, and also an MCT. And Rob, take it over.
Sure. Hi, Ron. I just kind of figure the most important bit of this slide is how to reach me. It's my email address is there, and my Twitter handle. You can see the stuff that I write. But anyway, my talk today is on in-memory operational analytics, and I don't actually want to use slides at all. I just want to use OneNote. Let's see how we go. So I want you to imagine a scenario. I want you to imagine a scenario where you have a person who's a customer, okay? This person has dollars that they want to spend with your company. They walk into your shop and they deal with a salesperson who has stuff that that they want to be able to sell. Now this store kind of looks like this. It's like, you know, it's a building, right? It's got windows and maybe it's got a second story that we in Australia call, like, you know, floor 1 as opposed to the ground floor. You know, it's got a big sign out the front and all that kind of stuff, and it's maybe got a space for cars and so on. This is a traditional shop. Okay, I'm not even talking about some online thing at this point. I'll move to that as we go. But this is a shop. Okay, we see customers come in with dollars, and they want to be able to see these dollars go across there, and the salesperson wants to be able to see the stuff that they're selling go across to here. And at this point, this is a purchase. It's an order. They have done some buying of stuff, okay? And when we consider how this is going, we actually kind of want to consider that the story is a bit more complicated than that. Now, if it's a small shop, what you'll often find is that at the back there's like a door, right? I'm sure you've seen this. You've all, like, you know, gone into shops and bought stuff and so on, and you'll often notice a door or sometimes a window, and behind that there's a desk, and there's somebody probably with a hat on, just because I figure this is the type of person that wears hats. And they're sitting there at some chair, right? And they are watching what happens in the store over here. This is the boss, B for boss, right? Or B for business if you want. I don't care. This is the boss guy, right? He or she is watching what happens. And this is how they evaluate how their business is going. Right? If it's a busy day, they want to see that there's lots of people in here. That person didn't come out too well. Let me draw their legs again. They want to see that there's a whole crowd of people. Ideally, they see like a whole queue of people even outside their store. This is how they regard the business as being successful. Right? These dollars are coming into where he or she is, and everything's good. Right? This is how they get a snapshot of what's going on now. Historically, well, they've got like this guy has a filing cabinet behind with a couple of drawers of things, and he can pull that out and be able to go through a big old list of files that show what the sales are like over time. But that's a big process. To see how things are going now, to see whether his day is good, whether his specials are working, to see whether he's able to meet demand, to see whether the queues are too long and maybe he needs to be able to consider putting on another salesperson, he looks through the door or the window to be able to see what is happening in the store. Now, from a data perspective, because I get that all of you people watching are data people, what we see is that as this sale is going on, what we see is that within the database there is a table for orders, and maybe there's a table for line items, and there's a table for customers, and so on and so forth. And we see that that as they're purchasing stuff, that there are insert statements going on, inserting rows into this. And this is your OLTP system. Now, you know this. I'm not trying to pretend that you don't. I'm just, you know, explaining it for background information and so on. Yeah, we see orders going on. We see line items. And at this point, when they hit buy, that's great. They mark the order as being done. The customer leaves the store, and that order is complete. No more activity on that order. At most, we might see that there was a delivery or something like that, but on the whole, that order is complete. Okay? Now, what happens on like a nightly basis is that this gets extracted to a much wider database called a data warehouse. I say wide because, you know, it's denormalized. It's designed for reporting. It's designed to not have to do too many joins, although it's got probably a star schema environment. But it's not Snowflake. It's been handled, right? We've potentially got data coming in from other sources as well. You know, there's all kinds of things going on here in this warehouse. But on a nightly basis, that data comes in from the OLTP environment into the warehouse. We then have a cube or something like that that gets processed or, you know, refreshed or whatever has to happen to this layer. This layer that produces a model. Maybe it's even it's done through direct query or rollup in multidimensional mode, but we have this other environment which then is used to be able to produce reports. Okay, so we've got our data warehouse, we've got our OLAP or our cube or our tabular model, and this then produces reports that get sent via email, maybe if it's subscriptions, or maybe they get written to a file system, or maybe the business user goes and actually runs a report on demand to be able to produce that. But this is what's happened yesterday. There is latency here, right? This shows us the data as it was overnight. We've got the history there. It's fantastically useful for having the history, but it doesn't show this business user what's going on in the system now. And you know what? They find that frustrating, right? They just do. It's just really annoying for them. They sit there, and in fact, I've seen this. They sit there, and you've got this guy sitting here with his hat on, using his laptop, and especially with an online system, it's much less likely to happen in the store. They go and buy something online, and then they start hitting refresh on their report, and they want to see that order they've just placed come through, and they don't see it until the next day. That's annoying. What they want to see is they want to have charts that show them, maybe they're bullet charts, maybe they're a line chart. They want to be able to see this chart going up because maybe it's, you know, Black Friday. Maybe it's Taco Tuesday, right? Apparently that's coming up. Maybe it's Blue Monday, and he's saying, how does it feel? He wants to see that sales are going up, and that his specials are working, and that the day was worth it. He doesn't want to see that there's a queue of people here outside his store that aren't being served because he doesn't have capacity. He wants to know how well his system is scaling. He wants to be able to get a feel for whether he's done things right and whether his IT people like you, have done things right. He really doesn't want to have to wait until tomorrow to evaluate that. He wants to be able to see what's going on. And worse still, you know what? He wants to do this thing called self-service reporting. Oh my goodness, what a nightmare that is for the people that are responsible for getting the data out here and through and so on, right? Look, actually, I'm okay with self-service reporting. Self-service BI and things like that, there was real fear when that came through from a lot of places. How do we make sure that this man or woman who's the business user here gets to be able to see what's happening in the business without that massive latency? Look, one option, by all means, is to be able to say, you know what, we could actually just make this process happen more frequently. Maybe instead of nightly, we want to have it like be 5-minutely, right? Is that okay? Is that something that your ETL developers are okay with? Is it, what are the problems going to be with that? Do you need to have a look at some sort of a thing where where if you were treating your cube as MOLAP, do you then need to be able to start treating it as rollup? Do you need to start using direct query instead of the in-memory model for tabular? Because it's all well and good to update your warehouse, but does your cube, and therefore the reports, see that change? If you're running multidimensional, then you need to reprocess that data all the time. Can you reprocess the live partitions? When I say live, I still mean with that latency of getting the data across into the warehouse and handling the slowly changed dimensions. And in fact, even handling the fact that these orders are very volatile when they first appear. That person who's gone into the supermarket and they're picking up their things and they're going beep, beep, beep. I shouldn't do it with my mouth, or I'll wreck where I am on the page. When you've got people in the store that are buying thing after thing after thing, there's pain with that. You need to be able to, if you're trying to pull that data through every moment that it happens, you're pulling a lot of information into the warehouse that maybe you don't care about. It's just that however slow you do that process, however quick, in fact, you do that process, you can turn it from slow into fast, but that's not going to be fast enough. You can turn it from fast into real time. And now that's what they want, right? They want to be able to see things as they happen. They don't want to see things the next day. They don't want to see things an hour later. They don't even want to see things 5 minutes later. They want to see things as they are now. Because now is all that matters. Edna from The Incredibles, I never look back, darling, it distracts from the now. It's a fantastic line, but it doesn't fit with data warehousing. Data warehouse is so much about the history. You want to be able to look at history, you want to be able to learn from the history. I'll come back to that as well. You want to be able to figure out everything you can about your business and what's happened in the past. But so often, the question that you're under pressure to answer is about what's happening now. This person here has a watch on, right? And they want to be able to see what's happening as soon as they put the order through, right? But more to that, you want to be able to look for anomalies. As data becomes more significant, and it really is more significant now than ever before. Like, people seem to worry when things started moving to the cloud, that would mean that that database administrators and data professionals might become less relevant. But in fact, they're more relevant than ever, because data has become more significant in every organization. Everybody wants to become data-driven, but to do that, they need now. It's all well and good to want to move to the cloud, but if it's actually just being a wet week because that's how fast everything is moving, then that's no good. If you've moved your warehouse to the cloud, you've still got this massive latency. There's still questions that aren't being answered quickly enough to be able to keep your business users happy enough. You don't want to be as slow as a wet week. That is not a good place to be in, especially when your business moves from being a physical thing to being an online presence, which so many are these days, with the capability of being able to answer who knows how many orders in a day. Especially if you have some special, you want to make sure that your system is coping with that. But you'll find that people want to be able to look at what's happening. I've had a number of customers over the years where they'll want me to be on site on their big day, whether that's an equivalent of a Black Friday. We don't have Black Friday here in Australia, but whether it's because it's the start of a new sales cycle for them, or because it's a particular holiday where they expect to do a lot of traffic, They want to be able to have me there so that I can monitor things, and I'm always seeing that people are wanting to run reports against the live system. So what's wrong with that? Well, when we have our customer, and our customer is dealing with the orders table here, and we have our business user here, okay? This is our customer. This is our business user, and our customer is doing things, and that's making rows appear in the orders table. And when those inserts are happening, and then when it's being updated while it's still being sorted out, and there's extra information being provided, there's extra items being bought, and they decide that they're going to do some shipping option, and all those different kinds of things that are going on with the order up until it's complete. There's lots of updates going on too. And every single one of them that goes on involves locks, right? And so if you've got business users that are trying to query this, and they're trying to run their analysis across this, and they're trying to aggregate across that data, well, yes, they're only taking out shared locks, but the customer here is trying to take out exclusive locks on that data. And they're just not compatible. You can't even take out a shared lock on a row if somebody's coming through and changing it. Furthermore, when somebody says, hey, I want to change this row, anybody who's got a shared lock on it will stop them from doing that for a moment. So that's potentially a problem, especially if you've got lots of these people. When you have lots of clients, lots of customers, going on, lots of client machines potentially, and they're all writing into here, and potentially you've got multiple business users as well, then you've got like a pain. You start to have issues, especially since this orders table now has to satisfy reports. That means that there's going to be indexes in place to handle this. So it's not even that these people are sitting here. These people are a little removed from it because there's a number of, this is the clustered index, but we have a number of non-clustered indexes going on as well. And these are the things that actually the queries are responding to. But every time there's an insert that goes into here, that insert here corresponds to a row here, and a row here, and a row here, and a row here on inside those non-clustered indexes. And whilst I love non-clustered indexes, don't get me wrong, I'm almost always happy to be able to say, let's get another non-clustered index on here because that's going to help this particular query when you need to go back and find something or whatever. I also am conscious of the fact that there is an amount of locking that goes on because this lock is now not simply here, but it actually stretches out to all these other indexes as well. And I don't care whether this business user is looking down this index or this one, or there's another person who's looking at this one. Those locks are locking resources on the non-clustered indexes as well. Okay, this makes a problem, right? It simply does. There's a problem here. Not only do we have concurrency questions about locks just within that one clustered index, but we also have locks being taken out on all these other. We've got an exclusive lock here, exclusive lock here, exclusive lock here, exclusive lock here. There's a lot of activity going on, which can cause pain. So how do we do this? Well, we've got to consider the fact that our problem is latency here, right? We don't want to have to move the data off to our warehouse. Now, please don't let me persuade you that the problem is the warehouse. You still quite probably need that warehouse because you've got these other sources coming in. You've got this star schema, which is useful. You've got history, which is useful. You've got your slowly changed dimensions, which is useful. You've got a ton of things that are very useful. And even if you've got temporal tables in 2016, don't think that that replaces the need for your data warehouse. But it doesn't solve the problem of having your business users wanting to run their real-time reports. Sure, you've got the option of being able to say, let's start introducing like a whole Internet of Things type approach and being able to actually ping those order details across to somewhere in the cloud, and they can end up in some data lake potentially over here. If they end up pushing into the cloud, it goes into a data lake. Then look, great. That might solve various things. But then is your business user here having to write queries against the data lake? Yeah, maybe one day, but not right now. I'm not convinced that that's necessarily the right answer that your business user is going to embrace. Even if they can write queries, I'm just not sure that they're going to like the idea of having their data now considered big data somewhere in the cloud, and how are they actually going to interact with that. The answer is quite possibly, though, operational analytics. Operational being the stuff that's going on live, your OLTP environment. This bit here is operational. Okay? And this bit here is your analytics. Now I need to not drag in from the side. This bit here is your analytics. Okay? The stuff that they're doing on the non-clustered indexes. We want to be able to explore how to do this. The way that we do it, and I'm just going to move to another section and quickly draw an equivalent for my orders table again. A way that we can do this is to consider column store. If this is our orders table, this would be this could well be our standard clustered index, which is row store. Row store being that every row is stored as a row. Okay? Those non-clustered indexes, they might be smaller rows, copies of only certain columns, but they're still stored by row. Has things like the business type. The white pages is a subset of that, but it's way smaller than the overall, you know, underlying table that might have all kinds of extra details. But it's still row by row, just a subset of the columns. Don't ever think that a non-clustered index is somehow column store, unless it's explicitly column store. If we have a column store index, then we have basically blocks of 1 million or so, but sometimes a lot more than 1 million row groups that are compressed, and it's the same data, but it's stored in a columnar way. All of the values for a particular column are stored for that particular column without the rest of the details. They'll have pointers and so on. It's an interesting data structure, but they're not stored by row. They're stored by column, and then you have the details about the things that have that value, and then you move to the next value and have the things that are in that value. It's the stuff that was Vertipack. It was inside Excel, inside Power Pivot when we first came across it. It's what makes tabular so fast. But here we have it inside regular SQL Server. Now I know that you're thinking that that we had it in 2012. Well, in 2012 we had non-clustered column store, but it was read-only. So you would go through that process of flowing your data through however frequently you wanted, and your data would flow through here. Actually, probably not that far, probably only into the warehouse, right? It would flow through there, and then you would turn on you would refresh, re-enable, rebuild your column store index on that, because it was read-only. And then your system is read-only until the next ETL process runs, probably that night. That doesn't get rid of latency at all, because you need to figure out how to solve that scenario. That's painful. Okay, you can do interesting things with partitions, sure, but nevertheless, there's pain involved, and it doesn't reduce the latency at all. 2014, we had clustered column store indexing. That meant that we could actually say, you know what, let's get rid of this completely. Let's just have the column store, okay? And then when our users, our customers come in and place their orders, those inserts are just going straight into the column store index. Now, that's not necessarily awful. When inserts happen, they go into a thing called the delta store, because we have all these different row groups, right? So we've got this row group here, and we've got this row group here. What goes on is that we keep inserting rows into the delta store, and that's a row store row group. Okay, it's basically a clustered index on the stuff that's coming in. And then when it reaches a certain size, it just says, okay, I'm going to close this. It was open. It's now closed. Okay? It's not accepting any more rows. Then at some point later, probably quite soon later, but nevertheless, at some point later, there's a separate process that comes through and picks up that closed row group and compresses it, and it then has a status of compressed, at which point it looks like this. That compressing actually takes the row store and flips it around to be, it's not really flipping it around, it's taking the chunks out of it and just kind of drawing lines through it like this as it kind of works out. It's just that it goes from something that we draw horizontally to something that we draw vertically. That's significant, right? It converts the row store storage into column store storage, and it compresses it. This is where we get the massive compression, like 10 times smaller compression. And at this point, it becomes really useful for querying. Now, this replaces the need for all those non-clustered indexes. You can query this nicely. The thing is the fact that these changes are hard. The reason why in 2012 it was read-only is because changing this data really is tricky. When somebody wants to change a row, for a start, a change is done by a delete plus an insert. I'll come back to that in a minute. Let's talk about how deletes work, though. A delete, ideally, it would search through the whole table and say, yep, here's this row that I want to delete. I'm going to find it in here somewhere. It's this one here. I want to delete that. Now, that entry there corresponds to this here, and 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 this here. That's annoying. When you want to delete a row and you have to then try and find where it exists in every single column store column, there's a pain. Across every row group as well. It's just hard. It's compressed. It would have to, it's hard. Trust me, it's not nice. So what happens instead is that deletes happen through a bitmap. It's basically a list of rows that are deleted in the table. So when it comes and says, okay, yep, here's this row, it can check the bitmap to see if that row is actually supposed to be there still. It can see the row. It's there inside the row group, but it's been marked as deleted in the bitmap. See, updating it, you would have to take the row take it from here and put it in somewhere else, and then that's not cool. So an update is done by a delete and then an insert, and the insert goes into an open Delta store. That row group that hasn't been closed and then compressed yet. Okay. Now, in 2016, we get the updatable non-clustered column store index. Okay. Now this is useful. This means that we can have our row store clustered index, fantastic, and we can have our non-clustered column store. So all our users, all our business users, I'm going to move this to the side for a second. Now that's not cool. That's not too bad. That was seriously scary. If there's one thing that I don't want to have happen when I'm giving this kind of a talk, is to have OneNote break on me. Look, I lost the change down here. But anyway, when we've got our business users here wanting to do queries against our data, do their analysis, their data science stuff, and so on live data, they can query this and they can query that nice and quickly. But there is still a problem about the fact that what's happening with our Delta store, what happens if our users are pushing all those rows in and then suddenly it reaches the threshold, but we're still wanting to update that row that's just been put into a closed Delta store and then a closed row group and then a compressed row group, and our users are still going, no, I'm trying to change that. That's annoying and painful. We'll end up with a lot of rows being just in the delete bitmap simply because they were still being changed when their row group got closed and compressed. It's not particularly ideal. Now, 2016 provides a couple of ways around this. Okay, let me kind of clear this again. We have our orders, we have our row groups. Okay, now when we've got lots of things being inserted into here, into our clustered index row store, we have like a hot area here. This is where changes are being made. In fact, I'm gonna circle that in red. We've got our hot data. These are the orders that haven't been finished yet, the ones that are changing, the ones that are having these updates run against them. Remember, updates don't work nicely with our compressed data here. Okay? So what we want to be able to consider is there's two ways around this. One is to consider filters. Two is to consider compression delay. Which is a new feature in 2016. Although updatable non-clustered index full stop is new, but I want to kind of consider how this leads on to clustered column store. I should never try and write on a whiteboard or on OneNote or whatever with that, but if I figure if I tell you what I've just written, you'll know for later if I need to refer back to it. So let's think about what we do with a filter. What happens if we say, you know what, our change here, the changing data here is a problem. Let's only accept rows into our non-clustered column store index when it stops being hot, when those orders get finished, and we end up with a cool session here. Okay, so these can then get inserted into our delta. Okay, now when that row group gets gets closed because it's seen enough rows and then compressed, well, that's okay, because those are rows that have stopped being hot. There's no more activity happening on them. Sure, they might have a greater risk of the person coming back and saying, no, I've changed my mind, but that can happen for older data as well, and that's not where the problem is. The problem is about orders where they're flying through and we're collecting data, and yeah. So that's an okay thing to consider, is this having this filter, okay? Now, the thing that I know that a lot of you are going to be asking is, well, what happens with the execution plans, right? I want to say let's run a query, but I'm drawing, so let's pretend that we're just looking at the execution plan for a query. We've got a select here, and we've got, this is pulling data from, and it doesn't just become a scan. Oh no, this is actually a concatenation operator. Weren't expecting to see that, were you? Huh. Anyway, and this is pulling data from 2 places. Maybe I should have used Plan Explorer for this. Would have probably done a better job. It's getting data from 2 places. It's getting data from our filtered non-clustered column store index, but it's also getting data from our delta. Sorry, not our delta, our hot data on our clustered index, but just the live stuff. This section down here. Right? So that can help a lot. At this point, there aren't locks being taken out on that cool data, so people can query that just fine. But this is still potentially a problem. There's going to be locks there. Right? Another option is compression delay. With compression delay, you could have everything going into delta. It's just that when the thing closes, it goes from open to closed, but then the tuple mover, this process that comes along and compresses it, this process happens straight away when it fills up. This process waits for some amount of time. It has to wait for however long the compression delay setting is set to. And this means that any changes that come through are less bad, because you can still delete out of a closed row group that's not compressed. You can still delete from it without having to do the bitmap. You won't insert back into it because of an update, but that certainly helps a lot. So that's another good option for being able to say, how do we stop all this activity against compressed row groups? But then we come and look at the clustered column store thing, and we still say we've still got an issue whether we're looking at these rows going straight into here, which is feasible because that's a clustered, because that's like an ordinary row store index. We can stop them coming up here effectively until later, but we still have this issue of locks, right? There's less to lock, because there aren't all these non-clustered indexes. These non-clustered indexes that I drew here would still be a problem, and that problem has been mitigated. Much less to lock now. But the way that we can get around this is actually the same way that we increase the number of customers massively, which is to look at in-memory, at Hekaton. Hekaton means that it can handle this in memory, and it has many fewer locks being taken out, much less locking, much less blocking, much less logging even, less pressure on the transaction log. You can satisfy the load that you want to have come through using Hekaton, and you can satisfy the indexing that you want using column store. When you combine these two, you actually make it so that this locking issue here is really not a problem, because you can pull the data out of here very, very easily. And at this point, it doesn't even matter too much if you're looking at clustered column store, or if you're looking at non-clustered column store with a row store underneath, the problem gets mitigated a lot. Bear in mind, all of this data you care about a lot less when you can access it all through your non-clustered column store. So memory-wise, you're saving your box significantly too. That data that you might want to be storing in RAM doesn't need to be stored in RAM nearly so much, because those non-clustered indexes are probably taking up like 10% of the space through compression. It's very nice stuff. Now, in my session at the PASS Summit, I'm going to be looking more at, I'm going to be following on from here and being able to look at what this means if you've got R in play. If you're doing analytics, advanced analytics using R, be able to looking for anomalies in the data, or doing advanced stuff that you want to still be able to look at the live data, but you want to be able to ask questions that require deeper analysis using the R language. And I'm going to show you how there's advantages to this kind of environment of Hekaton, having the in-memory with the non-clustered column store, and being able to push that data through R, the inbuilt SQL Server R services, where you don't have to then move it across to another machine or that kind of stuff. You can do it on the box itself, so that you can get proper real-time in-memory operational analytics in a way that should really be able to transform your environment. Now remember, as I'm saying all this, these queries that are running are the same reports and so on that your systems currently run. I haven't had to change any queries to make all this happen. I'm just changing indexes behind the scenes. I think that is remarkably significant. I think that this is the kind of thing that we'll see become more and more commonplace in systems over the years, and that tuning these kinds of environments will become a matter of making sure that your system can cope with the sheer volume of things coming in, because the database should be able to cope just fine using Hekaton and diverting the analytic queries through to column store indexes that are over the top. At this point, I'm going to thank you all for tuning in and pass back to Armando, who's going to ask any questions that have come up. In fact, I'm going to go back over here. I'm going to say, let's find out if there are questions.
Yeah. Yes, we do have a question in here. Rob, great presentation, by the way, very interesting. I love the scenarios you have drawn in there. We have a question here from Scott. The question is about the hot data. The hot data, is this a Lambda architecture?
I don't want to consider it really Lambda. I just kind of figure this is traditional kind of, this is just, you're collecting orders that you then are inserting extra lines into, and you're updating, DBO. You've got statements like update dbo.orders set total equals, what it was, like plus equals the amount from the latest item that you've added to it. Those kinds of things. You've even just got update statements that say yes, this is finalized. It's just data that I consider is still changing, because in general the process that somebody goes through from when they start the order or the thing or the the overall transaction of what's happening through to when it's done, during that time there's various changes happening within the database as they're deciding what they need to do and they're finalizing everything. You know what it's like. You create an order inside some online store, and you add things to your shopping basket, and eventually you say now go to checkout, and then you still continue providing more information. The worry, and the reason why I consider that a different kind of data, is that if that gets inserted into a Delta Store row group, and then that Delta Store row group gets closed because there's so many more rows coming in, and then gets compressed, then all of a sudden it's in this region where you don't want to be touching that row again because it's inside this compressed row group. And that's where you can get pain. You know? Like that's where you're going to wish that that you didn't have it up there in that compressed row group. You could still change it easily. So I mean, Lambda, I kind of figure, is the whole thing of being able to, you know, flow things through, you know, in a Internet of Things kind of environment using stream analytics and event hubs and all those kinds of things. I figure that's another way of addressing the question of how do you deal with data. But this is an environment which doesn't have to change your existing on-prem architecture for. You've still got the same tables that you've always had. You're just providing a way to let people run analytic queries against those tables without everything breaking. I hope that answers your question, Scott. Let us know. I don't see the questions thing at the moment because you'd all be able to see it because my screen is being shared. But hopefully you can let Amanda know whether that's sorted or not.
Yeah, Scott answered here. He said, "Excellent, thanks." We do have another question for you from Keen. The question is, what table design do you use? Relational?
Yeah, this is a relational database. This is an OLTP system that I'm considering here. This is the environment where people are. This is your existing environment where you are collecting the orders as they happen, and that's the table that I find that your business users want to query, right? Because they want to see, look, I've got all these people being busy. How many orders have we done today? And they ask people that question. They go, look, you know, how much have we made today so far? You know, I want to know whether I can afford to go and buy that jet ski or whatever, you know, business owners do. Not this business owner, but, you know, some apparently. You know, they want to query the live table, but that's the existing table that you've currently got in your OLTP environment.
So it's the current table with a column store index to it, right?
Yeah, you can add a non-clustered column store index in SQL 2016. You can add a non-clustered column store index to that table and use compression delay on it, which is in minutes, or use a filtered index. That can work too. But then that should be able to replace all the non-clustered indexes that you've put on it so that the business users' queries work nicely, you know, because you don't like scans across a clustered index. That's even worse, right? So you create these non-clustered indexes, but maintaining them is a pain and so on. And hey, that's what I just presented on. We can talk about that later if you're still missing something.
Right. Okay. Yeah, so these are the questions. For those of you who are interested in this presentation, there is, although Rob has not used any slide deck, there is a link here for you to find these questions and the answers later. So that has the link again on the chat window. Since we have no more questions,
I'll go through the questions that were, any questions that have been asked and so on, and I can see the questions thing flashing in the right-hand side of my screen. You can probably see that too. I'm not going to click on that right now, but Path is going to send me the list of questions, and I'll try and write something up about that. I might post something at SQL Blog about that. I'll see how we go.
Right. But you're good. You answered both of them, and definitely.
Well, there were only two, right?
Yeah, yeah, and
sure.
Definitely blog posts about them would be great. Can we
of
move
course, you know, the best way to get more information about this is to come to the Path Summit, because I'm giving this talk at the Path Summit. In fact, I am curious, and I would love some of you to write to me at, you know, my my email address or my Twitter handle to be able to let me know whether you think the drawing in my presentation thing worked, and whether you think I should try and campaign Path to get me like a Surface Hub for the wall, so that I can have a, you know, so that I can stand up at the Path Summit and draw during that. I'm curious to know what you, the audience, both of you, think about that idea. I don't know if it'll work, but I'm curious if you think it worked today, and you think I should do that standing up in front of an audience at the Path Summit, basically do a whiteboard talk.
Well, hopefully you'll be hearing from the audience here with us today. We had about 30 people or 40 people almost around, but I loved it. I'm definitely going to use it in my classes. Thanks for the idea. So stick around, guys. For the next session, we get MongoDB for the SQL Server Professional, presented by Nathan Youngman. And we still have 5 minutes for the next session, so it's a good time for a break. It's a good time for for some waters and whatever else you need. Got some more comments here for you, Rob. Absolutely worked greatly. Ninth, Rob, really good one. And the last one here. Hi, Rob. This is another question, though. Would you use Hackathon plus CCI in data warehousing fact tables that get updated frequently? So you answered that at the blog post and at the PASS Summit, right? Don't forget, guys.
I think Hackathon's a great technology in all kinds of ways. Pretty much anywhere that you can do it. I love Hackathon for ETL processes because I don't need to think about locking on that. I don't need to think about. I don't need to make sure that everything's logged. I can even get away with having delayed durability because if my ETL fails, I'll kick it off again from scratch. Inside a warehouse itself, I wouldn't go for in-memory column store necessarily. I'd probably just look at having column store tables there in the warehouse. I think that's probably enough, but I'd definitely use a Hackathon for ETL processes if the environment allows it.
Great, very good. All right, so thank you so much, everyone, and hang around for the next session. Rob, see you at the summit.
Thanks, Armando. It's great having a good moderator.
Have a good afternoon, too.